Next topic, further differentiation. So we're going to be differentiating trig functions, and then we'll do further differentiation with chain rule, and then we'll do integration with trig and integration with chain rule. Okay, then that'll finish the calculus topic. Okay, so differentiating sine, right? These formulas are given to you on your formula sheet. Okay, you'll see that table of standard derivatives. Okay, so derivative of sine equals derivative of cosine equals. Okay, so this is a wee instructional video that I'll share that with you. Okay, so if we have sine graph, okay, maximum 1, minimum minus 1, okay, 90, 180, 270, 360. If we were to draw the derivative of that, right, remember stationary points occur when the derivative equals 0. So this here, right, this derivative graph that we're going to draw, this is our 0, okay? Stationary points occur when dy by dx equals 0, so this is our 0, right? Anything above there represents a positive value, anything below here represents a negative value, okay? And that value, because the derivative, right, is directly related to the rate of change, which is the gradient, then anything above here is when the gradient's positive, and anything below here is when the gradient's negative, okay? So let's transpose this graph down here onto our derivative, right? So our original function y equals f of x, where y is sine x, okay? So this is y equals sine x. Stationary points occur when dy by dx equals 0. Here's our stationary point. Here's our derivative graph. So there is a 0, right? Stationary point, dy by dx equals 0. This is a 0 on our dy by dx, right? So that's a 0, okay? So first of all, pick out your stationary points, and there they happen when the derivative is 0, okay? This here is a positive gradient, okay? So on the derivative graph, it's above the x-axis, okay? So it's up here somewhere, right? From 90 to 270, it's a negative gradient, so we're down here, okay? From 270 to 360, it's a positive gradient again, so it's up here, okay? So we use the stationary points, right? And then we use the gradient, so we're really looking at the gradient of this graph and bringing it down onto our gradient graph. So what's happened? Let's just join this up, right? So this has to turn and go back through this point here. So that's going to look like that, okay? Stationary point, stationary point, stationary point, stationary point. Positive gradient above the x-axis. Negative gradient between stationary points. So this is all negative, so it's all down here. So if it has to go from here to here, then it will naturally have to join, okay? So it'll have to turn. And then from here to here, it's positive, okay? So it's above the x-axis, right? These values will be the same values that are up here, the 1 and the minus 1, okay? And this shape should be familiar to you, okay? So the derivative of sine is cosine. Okay, and that's a rule, right, that you'll just remember, and it's on your formula sheet as well. Okay, so cosine, we can do something very similar. There's a turning point, okay, here's a turning point, there's a turning point. Okay, so stationary points occur when f dash x equals 0, stationary point, stationary point, stationary point, right, 90, 180, 270, 360, okay? So at 0 there's a stationary point, at 180 there's a stationary point, and at 360 there's a stationary point. Negative gradient, okay, so from here, let's see if this helps. Right, so from here to here, it's negative, okay? From here to here, it's positive, right? So that's negative, that's positive, so that means it's above. Between 180 and 360, it's above. Okay, so that means that it has to go from here to here underneath, and from here to here above. Okay? So that graph looks very similar to this one. Okay, so our sine graph is in fact this one. So this has been reflected in the x-axis. Okay, the y value there was 91, it's now 90, -1. So your y values have all inverted, positive to negative or negative to positive. So it's a negative of sine. Okay, so it's a negative of sine x. Okay, so there is the reason. Alright, sine differentiates to cosine, cosine differentiates to negative sine. Okay, a wee trick I like to remember, just so if sine differentiates to cosine and cosine differentiates to minus sine, then if positive sine differentiates to positive cosine, negative sine must differentiate to negative cosine, right? And if positive cosine differentiates to negative sine, then negative cosine must differentiate to positive sine. Okay, and then that's your full circle there. Okay, so I'll say this SES, negatives here, just to help you remember. Okay, but you're given these ones, right? So sine differentiates to cosine, cosine differentiates to minus sine differentiates to minus cosine, and minus cosine differentiates to positive sine. Then that's you back to the beginning. Okay, so it's cyclical. I'll do another video for the examples, alright?